Okay, so I'm starting from preset. I have a cal already that I didn't expand, so I want to start with that so we don't spend time doing calibration. And here, so I'm in network analyzer mode, S11. I had 801 points, and I have WR90 or expand, and I reduced my IF bandwidth to 1 kilohertz. And what I have is I have about half a meter of waveguide, and at the end of it, I've shorted it. And if you look at the return loss, it's about, within half a dB. And I'm going to auto scale it just so you can kind of see what it looks like. It's, most of it is around, 0.3, 0.4, but then I have this one section in this frequency that kind of falls down. And you'll see that in the measurement because at some point, this average return loss is what we're expecting to see. And my average is more closer to 0.6 or 0.7 because of this. Earlier in today, I didn't have it, so it's something in my setup that's maybe loose that causes this. But either way, you can kind of see that's the expected return loss of a short. Now I'm going to go back to cap mode, which is what we're used to, and I will set it up to a measure distance to fault. Let's recall WR90. And then I'm going to change my points to 801, my stop distance to 1 meter, and then I will turn my calibration on. I had done the cal in network analyzer mode, but it applies in this mode if the settings match. So now cal is on, and if I bring this reference position down one, and now I'll do a marker to peak. And this is close to my 560 millimeters. I have 4 sections. Each of them are 140 millimeters. So that's sort of the end of it. And this shows about 2 dB return loss. I'm expecting closer to 0 because just like your setting where you have it shorted, it's shorter, but it's showing me 2 dB. I can also change my power if I wanted to match where I caled, which was there. But I think the peak that's where it is. So it's kind of, that's my distance to fault. But now the question is, how can we get this to be closer to that half a dB, which is what we expected it. So what I do here is I go to network analyzer mode, and I'm going to turn time domain transform on. And time domain transform is really the same thing as distance to fault. This is the core of what it does. And I'll kind of go through this. I said change start and stop times to match cap mode approximately and see the peak of the signal. And you can kind of either experiment or you can just do some math. I just do some experimenting. And actually the easy way to do the experiment roughly is to put on a marker and move it to the end, and that's kind of your stop distance of about 1 meter. It's it's a little bit more than we're doing here. It's 1.16, but that's okay. And then there's a few other items to do here. Is mesh setup. You want to tell the system that you're in waveguide, so you go mesh setup, cal settings. Oh, and I had this from before, but it wasn't preset. The default is coax, so you change that to waveguide. You enter the cutoff frequency. You should read this in the cat mode what the cutoff frequency is if you don't know it. And also this gets calculated, but you want to also go to the top line and enter the velocity factor. So whatever gets calculated here, you enter it there. And you also, this is the stuff I always miss, change the transform window, transform more window, and change this to max because that's, again, what it said in cap mode. So we're trying to get them to be apples to apples. So now if I do marker to peak search and peak, there's my 560 millimeters, which is, again, I have 4 sections of 140 millimeters each. Perfect. And my minus 2 dB. I made a note here at the bottom that in NA mode, we report it as a negative number. If I go to cap mode, we report that same thing as a positive number. That's just user preferences. Cap mode, people like to see return loss as positive. But now we've obtained the same measurement in both network analyzer and cap mode. But here we have a tool that we're going to be adding to cap mode to correct that 2 dB But to do that, we have to do these few steps temporarily. So we go to transform, we turn transform off. And then I do marker to delay, which is adding in a delay. And here's a delay of 4.9 nanosecond, and you can see that in the electrical delay exactly what the number was. And then I go back and I turn transform on. I don't see my peak because it ended up less than 0. So there here, you come to changing the start frequency to something smaller. And now you can again experiment here. I did -2, seems to work for my setting. And then I do marker, peak surge, peak. And now that's my -0.7 dB. The distance is not quite right. It's close. You know, in cat mode, we're applying a unique velocity factor to each point based on the frequency. Here we're using an average one, but this -0.7 is the expected return loss. So in your case, where you were seeing 8 dB, maybe you should be seeing closer to 2 dB or whatever you're expecting that to be. So it's this addition of this electrical delay that moves it and gives us the right return loss value. But the plan is, if this in fact does work for you and it gives you the right solution, then we will simply make a simple marker to delay or add a very easy feature, so you don't have to go through all this stuff. You would just come here, you would press a key, and instead of this 2.2 dB, then you would see the correct value.